Hey everyone, we have a little guest today. You can see him. So if he starts crying, sorry. But today we are looking at naming covalent compounds. So this should be a pretty quick lesson. And by the end of this lesson, you should be able to predict chemical formulas and names for simple compounds based on the bonds that are present. So specifically covalent bonds. Make sure to review covalent bonding before you get started on this lesson because that'll just help it go by a little bit faster. So let's talk about naming covalent compounds first. So the name and formula of a molecular compound, describe the type and number of atoms in that molecule of the compound. So we have to be a little more specific on these, but these tend to be much easier to name than ionic compounds. There's a lot less rules. So since the elements in a molecule are both nonmetals, the first one should be the one that's the most metallic, so the most left on the periodic table, either furthest left or lowest in the group. So if they're in the same group, the one that's the furthest down. And then the second element, and when you name that first element, you don't change its name. So if it's nitrogen, leave it nitrogen. But the second element does get the IDE ending, just like ionic compounds. So for example, here you go, buddy. For example, we've got CO2. And usually when I give you a formula, it's already going to be in the order that you need it in. It's okay. Here you go. It's going to be in the order that you need it in. So like I've already got it in the order that it needs to be named. So we've got CO2. And CO2 becomes, it'll click through, there we go. So CO2 becomes, it's okay, carbon, and then we've got oxygen, which becomes oxide. However, which we'll see with these next two examples, we have to pay attention to these subscripts now. So we've got N2O4 and NO2. These are made up of the exact same elements at different ratios. So we've got to figure out how to name them. We can't name them both nitrogen oxide because then we don't know which one we're looking at. And they are two completely different compounds. It's okay. It's okay. So to fix that, we have to actually have prefixes which are noted by the subscripts. So we look at these subscript numbers that we've got, and we've got prefixes that go with them. So if you have no subscript, then your prefix is mono, but it's important to know that if you only have one of the first element, we do not put mono on the first element ever. But then if you have two, a subscript of 2, that becomes di, a subscript of 3 is tri, and you can see the list here, so make sure you have those in your notes. So CO2 would actually be carbon, not monocarbon, carbon dioxide. N2O4, there we've got a subscript on the first element, so we do have to add a prefix. So that would be dinitrogen tetroxide. So for oxygen or oxide, you do not include the O or A on the prefix. You just kick it off because that's like too many soft vowels or hard vowels together. So for the prefix for 4 is tetra. You get rid of that A and it becomes tetroxide. Then NO2 would be nitrogen dioxide. So now let's just go through the name. So we just did this one as an example a second ago. So we named the first element, which is carbon. Second element gets the IDE ending, so that would be oxide. Use subscripts to determine the prefixes that we use. So carbon has no subscript, which means no prefix since it's the first element. Oxygen has a subscript of 2, which is the prefix di. So our name is carbon dioxide. Don't put mono on your first element if no subscript is present. So you go ahead and you try this example with PBr5. Okay? Pause the video and try that. Now let's talk about how to write formulas for covalent compounds or molecular formulas. So writing the formula for a molecular compound is pretty easy. First, you write the symbols of the elements in the order that they appear in the name. So again, I'm going to give you the order that they need to show up. Prefixes tell you the subscripts, so vice versa. Now, if you see a prefix in the name, we know that that becomes a subscript on that element. If there's no prefix, then we assume that the subscript is 1, which means we don't write it. So here's the name, octaphosphorus heptoxide. So the prefix octa means 8, and our element is phosphorus, so we put the symbol for phosphorus, which is P, and we give it a subscript of 8. Then we have oxide, so we put the symbol for oxygen, which is O, and the prefix hept or hepta is 7, so we put a 7 as our subscript there. Very easy. So let's go ahead and do this one together, and it's the formula for diphosphorus tetrafluoride. So first, we're going to write the symbols for our elements, which for phosphorus is P, fluoride is F. Use the prefixes to determine your subscripts. So di is 2, so phosphorus will get a subscript of 2. Tetra is 4, so fluorine will get a 4. Also, keep in mind, most of these prefixes make total sense, like di, tri, hexa, hepta. Those are all ones you've heard before. 4 is the only one that's different for tetra, so just make sure you remember that. And then you put the subscripts with the elements and combine for the formula. So the answer here would be P2F4. And now I want you to try nitrogen triiodide. All right, guys, so that was very quick and easy, much easier than ion.